Forced air supply to the internal combustion engine allows increasing its power. The process of supplying gas under pressure is technically called supercharging. The compression of air and its supply to the engine is provided by the compressor. For the compressor to start working, its shaft should be rotated at a high rotational speed, tens of thousands of revolutions per minute. In engines with turbochargers, a turbine is used for this purpose. The turbine's working wheel is rotated by the exhaust stream. We've talked about how the turbocharger works in more detail in one of the previous videos. For the turbine to rotate, there should be a powerful exhaust stream, but at the start, this stream is very weak. This fact explains one of the turbocharger's main disadvantages, turbo lag. When the exhaust stream is not sufficient, the turbine cannot rotate the compressor shaft at a high speed, which means that the compressor cannot supply the necessary pressure. Moreover, the sockets and working wheels create additional resistance to the gas stream. So there's resistance, but there's no effect from the work of devices. In this mode, the performance of the engine with the turbocharger can be worse than that without supercharging. Of course, the turbocharger can catch up by working in other modes. Is there a way to eliminate turbo lag? One of the ways to do it is to use an electrical engine. We could get rid of the turbine by using an electric drive to rotate the compressor shaft. Resistance in the exhaust line will decrease, but the supercharging will stay. The electrical engine rotates the compressor shaft with the working wheel installed on it, and the blades on the wheel accelerate air particles. Accelerated particles move into the periphery and get into the volute casing, where a part of the velocity head transforms into pressure. The air compressed by the compressor is directed to the engine intake manifold through the intercooler. The shaft rotation speed of the electrical engine is relatively easy to adjust, which allows achieving the most efficient control and cost-efficient operation of the electric supercharger. Unfortunately, this scheme is not without disadvantages. First is the need to rotate the compressor shaft at a high speed, because not all electrical engines can withstand this mode of operation. Second is the need to power the engine from a generator or accumulator. You will need a powerful electrical engine to rotate the compressor shaft at a high speed, and to power this engine, you will need to significantly increase the power of the generator and batteries. Today, the most effective solution is an electric turbocharger. Let's add an additional electrical engine to the turbocharger system. At the start, the electrical engine rotates the compressor shaft, eliminating the turbo lag from the supercharging system. When the powerful exhaust stream is formed, the turbine starts working and ensures power saving. Surplus energy on the turbine can also be used if an electrical engine capable of operating as a generator is installed in the system. This scheme is quite complicated and the cost of the devices included in it is high, so it is used on sports racing cars, where the effect of a turbo lag on the operation of an internal combustion engine can determine the outcome of a race,